So as you can see from this, the 2R and the 2R has to be treated as parallel, because there's a wire which is coming like this, which shows the current is getting split up. So it's 2R into 2R by 2R plus 2R, R1 R2 by R1 plus R2, 4R square by R 4R, R and R get cancelled, 4 and R, so equivalent resistance is just R. But you should know that when an 8 ohm resistor and an 8 ohm resistor are connected in parallel, then obviously it will be 4 ohms. Okay, you don't have to really do this. If it's R and an R, if it's R and an R and they connected in parallel, the equivalent resistance will be R by 2. So when a 2R and 2R are connected, the equivalent resistance is just R. You can just finish the sum like that. So let's go to next question. Can you see this sum? This 30 ohms and this 30 ohms are in series. So then 30 plus 30 is 60. Once that is done, that is in parallel with this 30 ohms, because there will be different current. This will have a different set of current. I will mark it in red color. These two will have a red color current, which is different current. So then therefore, the 60 and the 30 are in parallel. So 60 into 30 by a 60 plus 30 is 60 is 18 by a 90. So 9 2s are 18. 20 ohms is the equivalent resistance still here. So that is the equivalent R equivalent of the circuit. You know that I is equal to V by R, 2 by 20. And so it's 1 by 10 amps is the current that's flowing through here, which is 1 by 10 amps. But now the question is, what will be the current through here? It's very simple. Since these are connected, this one, the black color wire is connected in parallel to the 2 volts. The entire 2 volts comes here. So I is equal to V by R, 2 by 30, which is 1 by 15. So 1 by 15 amps flows through here. And the total of 1 by 10 minus 1 by 15 is what flows through. 1 by 15 is what flows through AB, and what is going to flow through the red color arrow mark that I have mentioned here. To find that, you just do the total 1 by 10 minus 1 by 15, which will be 30, and 10 3s are and 15 2s are, so 1 by 30. So then therefore the current that's going to flow through here is, the red color is 1 by 30 amps. 1 by 30 amps, is it correct? Let's add up 1 by 30. Okay, so 1 by 30 amps. Let's add up 1 by 15 and 1 by 30. 1 by 15 plus 1 by 30, that LCM is 30. 15 2s are 30. 2 plus 1 is 3 by 30, which is 1 by 10, which is the total current. So everything looks perfect. So this is how way you calculate. So let's go to next question. So that's done. The question is, what is the current that's coming? The total current only is the question here. But I taught you how to find the individual currents also. Okay, so then here let's go to this sum. In this 5 ohms and this 10 ohms are in series, which makes it 15 ohms. And that 15 and this 10 are going to be in parallel. So it's 15 into 10 by 15 plus 10. 15 into 10 is 150 by 25, and 25 6 are 150, 6 ohms, and that 6 ohms and this 18 ohms are going to be in series. So 18 plus 6 is equal to 24 ohms, and this is the 24 ohms is the R equivalent. Therefore you know that R equivalent, the total resistance itself is 24 ohms, and I is equal to V by R, which is 60 by 24. Can cancel this with 6 4s are 24 and 6 10s are, which is 5 by 2, which is 2.5 amps is the current which flows through here. The 2.5 amps flows through this, and this is like a main house. Can you see? And these are all outhouses which are being rented by people. Let's assume it like that. Okay, so then therefore you know that the voltage that's taken away by this 18 ohms is 18 into 2.5. What is 18 into 2.5? 18 2s are 36. Plus 9, 45 volt goes here out of the total of 60 volts. The balance 15 volts is what is going to be for this black color wire and also for this red color unit, because they both are parallel. This will also receive a 15 volts only. The moment you know the resistance and the voltage, you can find this current. I is equal to V by R. I is equal to V by R, where 15 by 10 is 1.5 amps, and this is 1.5 amps which flows through this black color wire. The total current itself is 2.5. Therefore, through the red color wire, there's only 1 amp which is going to flow through. So the complete wire here is going to receive only 1 amp. And so the question is only what is the voltage across R1. We already found it, and I told you voltage across R2 is 15 volts. And so we are only doing extra. Let's go to the next question. So in this sum, if you see, these two resistances are in series. R2 plus R3 is in series, and they have given each of them to be of the value, I think each of them were of the value 2 ohms. I think so. R1, R2, R3 is series. I don't remember the question, but 1 second, let me see. So I'm reading the question for you. Here it is. A letter A consists of a uniform wire of resistance 1 ohm per centimeter. The sides are each 20 centimeter long, and the cross piece in the middle, as you can see, the cross piece in the middle is 10 centimeter long. So this whole thing is 20 centimeter long. Cross piece in the middle is just 10 centimeter long, and while the apex angle is 60 degree, this angle is given to be 60 degree. Find the resistance of the letter between the two ends of the legs. So then between this and this, what is the equivalent resistance? So if you know that resistance per centimeter is 1 ohm, and so how many centimeters is 20 centimeters? So this is totally 20 ohm. Exactly, it's getting cut in the middle. So this is 10 ohm, this is 10 ohm, this is 10 ohm, and this is 10 ohm, and this is also 10 ohm. Thus, with that given information, you find all that, and it's an equilateral triangle, obviously, and so then 60 degree has been given. Okay, so then that's what it is. Every resistance is just 10 ohms. The moment it's 10 ohms, R2 and R3 is just 10 plus 10 is 20 ohms. That is going to be in parallel with R5, which is another 10. So 20 into 10 by 20 plus 10. So this and this get cancelled, is 20 by 3. That's going to be in series with this 10 ohms and this 10 ohms. So 10 plus 10 is 20 plus 20 by 3. It's 60 plus 20 by 3, which is 80 by 3 is the R equivalent in this case. Okay, so let's go to 80 by 3, which is 26.67. Okay, let's go to next question. The next question is in here. Can you see that they're asking for the voltmeter reading here, which means you should know the current through this 4 ohms. If you know this current alone, you can multiply it with 4 ohms. So to get that current, you have to find the equivalent resistance, and the 2 ohms, this 4 ohms and 2 ohms are in series. So 4 plus 2, 6, 6 plus 2, 8 ohms are in series. That 8 ohm and this 8 ohm are in parallel, which makes it 4 ohms. You don't have to calculate. 8 and 8 in parallel means it's 4 ohms. That is going to be in series with this 2 ohms and this 2 ohms. So 2 plus 2 is already 4 plus 4 is 8 ohms is the R equivalent. Once you know the R equivalent, you can do I is equal to V by R. So 6 by 8, which is 3 by 4, and that is the total current. So am I right? So the 2 plus 4, 6, 2 plus 4, 6, 6 plus 2, 8, 8 and 8, 4, 4 plus 2, yeah. So 4 plus 2 plus 2 is 8. I is equal to V by R. V is 16, sorry. 16 by 8 is just 2 amps is the current that's flowing through. The moment you see this, you write 2 amps in here, and that's what is going to go out and come into the battery, 2 amps. So the voltage here is 4 volts because V is equal to IR. This 2 amps into 2 ohms, and here also it's going to be 4 volts again because it's 2 amps and 2 ohms. V is equal to IR. So totally put together, the 4 volts and 4 volts make it 8 volt. And once you get that 8 volts here, you know that it's going to take away 8 volts. The balance only is 8 volt is left across this also and across this also. So once you know this is only 8 volts, you can get the current to be 1 amps here. Out of 2 amps, 1 amp flows, there's only a balance of 1 amp here. And then if 1 amp is going to flow through, 4 volt will be the reading across this. So let's go to 4 volts. That was so easy. So this is the way you have to do this sum. I hope you're clear. Let's go to next. it's this sum, and wherein you can see that this 1 ohm and this 1 ohm are series, so that is 2 ohms, and this 2 ohms and this 2 ohms are series. So there's a 2 ohm and a 4 ohm which are in parallel. So 2 into 4 by 2 plus 4, which is 8 by 6, or a 4 by 3. And you know the 4 by 3 is the equivalent of this multiplied by 1, 2, 3, 4. There are 4 sets like this. So into 4, 16 by 3 is the R equivalent, because these are all in series. So let's go to the next question. So this is about two wires with creative cross section A1 and resistivity ρ1. They are connected in parallel. When two wires are placed like this, it obviously means they both are in parallel. The equivalent resistance is resistivity rho equivalent. They are asking, you know, 1 by R is equal to 1 by R1 plus 1 by R2, and you know 1 by R1 is ρ1 into L by A1 plus 1 by ρ2 into L by A2 is 1 by rho equivalent into L is the same, but A is A1 plus A2. So from this, L throughout can get cancelled. You can find what is rho equivalent after taking an LCM ρ1 into ρ2. A1 ρ2 plus A2 ρ1 is A1 plus A2 can come down, and that will be 1 by rho equivalent. And so rho equivalent itself is ρ1 ρ2 into A1 plus A2 by A1 ρ2 plus A2 ρ1, and that's an interesting question to find this. And so let's go to the next question. So let's look at this. So you have a plain wire like this. A plain wire is like this. This point and this point are at the same potential, because it's simply a plain wire, and so then therefore these 2 points are at the same potential. So therefore you can ignore this. This is like a plain wire again, which means this 2 ohm resistor is going to get shifted here, and you can ignore this, and the circuit converts itself into like this. And you know this 2 ohm and this 2 ohm are now in parallel, and so it's 1 ohm. That 1 ohm and this 2 ohm are in series, so it makes it 3 ohms. That 3 ohm, this 3 ohm and this 3 ohm are all in parallel. So 1 by 3 plus 1 by 3 plus 1 by 3 is a 3 by 3, which makes it 1 ohm is the equivalent resistance. So let's go to this sum. See, whenever they give you a sum, when they are asking you the equivalent resistance between A and B, they will say effective resistance between a point A and B. Then you should extend this wire. Imagine that there is a circuit further which is extended from A and B, so which shows that this 3 ohms is going to be in parallel with the entirely above thing. It's going to be completely in parallel, and you cannot come from therefore you have to start this from this 3 ohms and this 3 ohms. They both are in series 6 ohms. That 6 ohm and this 6 ohms is going to be in parallel, so 3 ohms. That 3 and this 3 are in series, so 6 and this 6 ohms makes it 3. 3 and 3 makes it 6, and 6 and 6 makes it 3. 3 and 3 makes it 6. But that 6 and this 3 are going to be in parallel, so 6 into 3 by 6 plus 3 is 18 by 9, so it's 2 ohms is the equivalent resistance. So let's go to next question. So next question, if you see this switch is open, so no current is going to flow through here. This middle wire can be ignored. So these two are in series, so it's 18. And these two are in series, which is another 18, and they both are in parallel, so 9 ohms is the R equivalent. We're done. But there is another question, second part of the question, wherein they will tell you, one second. So now I'm going to close this circuit. So this and this will become parallel, which is 6 into 12 by 6 plus 12. So 6 into 12 by 18, 6 3s are 18 and 4. And that's going to be in series with this, you know, this and this are series. So 4 2s are 8, and 8 ohms is the equivalent resistance. So these are the two conditions. So let's go to next sum. In this sum, if you see, this 10 ohms and this 10 ohms are in series, which will make it 20 ohms. Now let's do it in red color. This 10 ohms and this 10 ohms are in series. No, sorry, this is not series. If there is a hook like that, if they had given a hook like that, we can take this and this in series, which is like, but it's not given like that. So then therefore there's no hook, and so then therefore I have to treat these two to be parallel. So 5 ohms, these two to be parallel 5 ohms, those two to be in series, so 10 ohms. That 10 ohm at the center is going to be in parallel with this top 5 ohms and a bottom 5 ohm, and they're all in parallel, so 1 by 5 plus 1 by 10 plus 1 by 5. 10 is the LCM, so it's 2 plus 1 plus 2 is 5 by 10, which is 1 by 2, and thus you get the equivalent resistance. And suppose they ask you for the current, then you put I is equal to V by R. Okay, so then calculate the current. Okay, through the entire circuit, I is equal to V by R. I is equal to V by R. I is 10 and R is 1 by 2, whatever we calculated. Then write the answer. So 1 by 2 is the equivalent resistance. Yes, correct. And you have to put it as so it's 2. R is the equivalent resistance, which will be 2, because it's 1 by 5 plus 1 by 10 plus 1 by 5. That will be 2, and it will be 5 by 2, and so the R equivalent is 2 ohms. Once you find R equivalent to be 2 ohms, just substitute it here, and then you get a current to be 5 amps, and that's the total current which is going to flow through. And you know that for this 5 ohms, now they ask you the respective current, this 5 ohms, and for this 5 ohms, the total voltage is just 10 volts only, because they are parallel. I is equal to V by R, 10 by 5, 2 amps flow through here. So out of the 5 amps which is coming through, 2 amps flow through here, and 2 amps flow through here. Obviously in the middle wire, all of this, we consider this to be parallel, this to be in parallel, and so we found it to be 5 and 5, and those to be in series, we found it to be 10. So out of the middle 10 ohms resistance, there's going to be only 1 amp flowing through, and thus we are able to find the value of the current through each of these networks. So that's about it. So let's go to the next sum. So don't forget to reciprocal the resistance. So next is this one. It's a very, very important sum, where I wouldn't do it like how SLR has done. I would first of all, the question is about steady current or a steady state or fully charged capacitor. The 3 keywords: steady current, or a steady state, or a fully charged capacitor. Capacitor means it will block a DC. It will block DC. So the moment it blocks the DC current that's flowing in, there's no current flowing through, and you can ignore this. So the resistance is 2 ohms and 1 ohms, which is 3 ohms is the equivalent resistance in series, and the voltage is negative, and negative is connected, so it's E1 minus E2, so then the equivalent voltage is just 12 minus 6, which is 6 volts, and I is equal to V by R, and so 2 amps is the total current which flows through here, which is the same current which flows through here also. So moment you found the current, now we're going to have a different approach. We're going to do Kirchhoff's loop rule. It's not a closed loop though. For an open loop, we're going to, the potential across, I'll just tell you, the potential across C and D will be equal to potential across B and E. The question is to find the voltage on the capacitor and eventually find the charge on the capacitor, which is Q is equal to CD. So for which you need the voltage across the capacitor. So then the voltage across CD will be equal to voltage across B. To find the voltage across CD, I'm going to come from D onwards, and I'm going to apply a loop rule. When I'm coming, the resistance 2 ohms is there, where the current 2 amps is coming in the opposite direction. So 2 2s are 4, and the battery is from positive to negative, which is minus 12, which shows that there's minus 8 volts is the potential across CD. It's the same potential which will be across BE also. So I'm going to come from BE, E to B, and when I come, there's a voltage across the capacitor which I don't know, and I come from positive to negative. It's minus 6 is equal to minus 8, because this answer and this answer has got to be the same. So VC is minus 8 plus 6. VC is equal to minus 2. Thus the voltage across the capacitor is now voltage across the capacitor. Thus you found it to be 2 volts. Forget about the minus sign. and the charge is Q is equal to C into V. The capacitance is 5 into 10 to the power minus 6 farad into voltage. And what is the voltage? Is just 2. 5 2s are 10 into 10 to the power minus 6 coulomb, or 10 microcoulomb is the answer. So this is the way, which is a better way of doing. Just make sure that it's not a closed loop though. If it's closed loop, I'll say the net potential is equal to 0. Since I'm doing it from the point D to C, I get the potential difference between CD. Okay, so I hope you're clear. So let's go to next question. Let's go to next question. This is it. It's similar to the last sum, where if you see, they're asking for the voltage across the capacitor. The voltage across this capacitor. Okay, so for which you know the voltage across these 2 points, across this and this, whether you come through that route or you come through this route, will be the same. Okay, so then basically a fully charged capacitor blocks a DC. You can ignore this. Therefore, R1 and R2 will be in series. The value for R1 and R2, everything is 2 ohms here. A 2 ohms and a 2 ohms is in series, so 4 ohms. That is going to be in parallel with this R3, which is another 2 ohms. So 4 into 2 by 4 plus 2 is 6. So 4 by 3, and that's going to be in series. That entire network is going to be in series with R4. So then therefore it's 4 by 3 plus 2. So then thus you get 4 by 3 plus 2, which is 10 by 3, and that will be the current that's going to flow through, and that will be the equal resistance, and I get I is equal to V by R. It's 10 by 3. 10 and 10 get cancelled. 3 amps is the current that's going to flow through here. So this is 3 amps. 3 amps. And the moment you know this is 3 amps, you know the resistance here is 2 ohms. And this is the separate house, you know, this circuit is removed. So this is the owner's house kind of a thing, where this resistance receives a current of all the 3 amps. And the resistance is 2, and so then the current voltage here is 6 volts. Once you know this is 6 volts, balance of 10 minus 6 is 4 volts is what is here through this R3, and also through the rest of this R1 and R2 also. It's going to be 4 volts. You know this is again 2 ohms, and I is equal to V by R, and so you understand that 2 amps is the current that's flowing in here. Out of 3, 2 goes in here. There's only 1 amp which flows through the balance of the circuit. So 1 amp is the current that's going to flow through here as well as here. You know this is 2 ohms and this is 1 amp. Okay, so then therefore it is 2 volt across this, the 6 volt across this. A 2 plus 4 is 8 volt will eventually be the voltage across here also, but no current is coming through this resistor, so all the voltage will go to this capacitor, which is 8 volt. Okay, so that's about it. So next is next question is this: when you have again a simple wire which runs through here and here, I told you that this point and this point will be at the same potential. This point and this point will be at the same potential. So therefore I'm not able to remove any resistor here, because there's a potential difference between these two. So current will definitely flow. I can't ignore anything. So I'm going to draw a color with this color pen. You see this is connected to R. This is also connected to this 2R and R. Similarly, come from the other end. This is connected to this R. It's also connected to this and this. So then there shows that the red color point is connected to a 2R, a 2R and an R. And the blue color point is also connected to this, and that shows that they are all in parallel. So 1 by 2R plus 1 by 2R plus 1 by R. So the answer is 2R into 2. 2 plus 1, 3, 3, 4. So 2 by R. As they are, you have to reciprocate. Don't forget that R by 2 is the equivalent resistance, which is answer for that question. So let's go to this sum. In this sum, you see that the moment I see this, I see that this 3 ohms and this 3 ohms are in series, which makes it 6 ohms. That 6 ohm and this 3 ohm are in parallel. So 6 into 3 by 6 plus 3, which is 9. 6 3s are 18 by 2 is 2. That 2 and this 3 are in series, so it's 5. So then therefore I know that the top is completely 5 ohms. Middle one The top one is 5 ohms, the middle one is also 5 ohms, and similarly these are all going to account another 5 ohms. So 1 by 5 plus 1 by 5 plus 1 by 5, because they are all in parallel, because they have given across AB, which shows that this is going to be parallel to the one at the top and one that is at the bottom. So 3 by 5, which will become 5 by 3. That will be the equivalent resistance through the circuit. And so look at this sum. The moment you see this, you should identify that there is a Wheatstone's bridge. The R by R, P by Q is equal to R by S, R by R. So there is no current which will flow through the middle wire. These two will be in series, which is 2R. These two will be in series, which will be 2R. Similarly, this is also another Wheatstone's bridge, where R by R is equal to R by R. No current will flow through the middle wire. These two are in series and these two are in series, and the entire 2R, 2R, 2R are parallel. So it's 1 by 2R plus 1 by 2R plus 1 by 2R plus 1 by 2R, which will make it 4 by 2R, and this get cancelled. You have to reciprocal it, don't forget it, that will be R by 2. So that's about that sum. Look at this. The moment you see this, you can't jump into conclusion that, oh my god, I have a Wheatstone's bridge here. No. Because the Wheatstone's bridge should be exclusively Wheatstone's bridge, like on the top and the bottom, pakka it's a Wheatstone's bridge. Whereas here, if you see, there's something else that is here, so you can't categorize this as a Wheatstone's bridge. You have to do it with mirror symmetry. Aurora would not have done it like that. You have to cut this into half, where this is R by 2 and this is R. They both are in parallel, and that answer will be in series with this R. And they've given across AB, so then therefore you can't include this resistor. You have to include only these two, R by 2 and R in parallel, R into R by 2 by R plus R by 2, which is R square by 2 by 3R by 2. So R and R get cancelled, R by 3, and that is in series with an R, this R, this one. So then therefore it's 4R by 3. This will be a 4R by 3, and this is an also 4R by 3, and there's an R. So all of them are in parallel. 1 by 4R by 3 plus 1 by 4R by 3 plus 1 by this middle one, which is an R. They are all in parallel. So into 4, 3 plus 3, 6 plus 4, 10, and you have to reciprocal this. So it's 4R by 10 or a 2R by 5 is the equivalent resistance for the left hand side, into 2, because they both are in series, so into 2. So 4R by 5 ohms will be the equivalent resistance. I am doing it using mirror symmetry. Left LHS is equal to RHS. Okay, look, let's go to this sum. In this sum, oh my god, I am able to identify a Wheatstone's bridge, because R by R is equal to R by R, so no current will flow through the middle wire. The question is about across AB, so this R will be totally in parallel with what was above. Don't forget that. And so then these two are in series, which is 2R, these two are in series, which is 2R, and those two are in parallel, so then that's just R. That R and this R are again in parallel, so R by 2 is the equivalent resistance. So let's go to next sum. In this I will do it using mirror symmetry, because I will be able to cut it exactly in the middle, where this will be R by 2, this will be R by 2, this will be R by 2, and this is still R. Let's look at only the left hand side. Look at these two. The question is about potential difference between the equivalent distance between B and C. So what is the bottom should be considered totally in parallel with what is at the top. So now let's take only this. This R by 2, and this R by 2 are totally in parallel. So 1 by R plus 1 by R by 2 plus 1 by R by 2. So which is 5 by R, or R by 5. And this totally is an R by 5, and that is going to be in parallel with this R by 2. Oh, so can I treat all of them to be just in parallel? That is this R by 2, that R by 2, that R, and this R by 2. All of them can be in parallel. Or anyway is fine. You will still get the same answer as whatever I am doing. So answer has to be R by 3. So if I take it as 1 by R plus 1 by R by 2 plus 1 by R by 2 plus 1 by R by 2. R will be LCM. 2 plus 2 4, 4 plus 2 6, 6 plus 1 7, is it? Entire thing above has to be treated as parallel with this. Okay, 1 by R plus 1 by R by 2 plus 1 by R by 2. So what am I getting? So no, I don't think I'm getting an answer. We'll explore. So you know this is R by 2 and this is R by 2 and this is R by 2 and this is R. We for sure know that these three are now in parallel. 1 by R plus 1 by R by 2 plus 1 by R by 2. So it's 2 plus 2 4, 4 plus 1 5. That is going to be in parallel with this R by 2. So 1 by R by 5 plus 1 by R by 2. Yeah, you still get the same answer either way. And this whole thing and this are in series. Same setup, mirror symmetry into 2 is 14. So did I reciprocal it? It's R by 7. And I have to multiply it twice. So it's 2R by 7 is what I'm getting. Let me check. Guys, I seem to have made a mistake. This only is R by 2. This is only R. And this is R. And this is again R by 2. All of them in parallel. 1 by R plus 1 by R plus 1 by R by 2 plus 1 by R by 2 is 2 plus 2, 4, 5, 6, 6 by R. And this is R by 6. And you have to multiply the whole thing with a 2 because this whole setup is in series. And so the equivalent resistance is R by 3. Yeah, correct. I made a mistake. I hope you're clear. So let's go to next sum. Oh, that's all. So this recording is over.